So my name is Grobbel. I'm a senior here at Grandview High School. This is my senior STEM project. It's called the gyro rocket. So first, a little bit about me. I've been here for 4 years now. I've played volleyball here for 4 years. I've also played club volleyball for 6 years. Here I'm involved in clubs like NHS, Spanish Honor Society, Women's STEM, etc. I've also taken a bunch of CCIC classes, including Aviation Fundamentals, Drone Piloting, CNC Machining 1, and Manufacturing Fundamentals. In the future, I'm going to CU Boulder, Skill Buffs, and I'm going to major in aerospace engineering. So the inspiration for my project was Moon's Falcon 9. If you don't know anything about the SpaceX rocket, it's a self-landing rocket. It uses a multi-directional motor, as you can see down here. Land itself, and once the smoke clears, you can see it has landings. In the newer models, they have deployable landing gear, so I figured I would do something similar. Granted, I'm a high schooler and I have a high school budget, so I had to work around that. So my project was to hand make my own model rocket. I wanted to incorporate a reaction wheel inside to control the roll of the rocket. This would spin the opposite way of the rocket and hopefully control the spin. So I need a lot of technology for this project. My first was, of course, the reaction wheel. I was going to make this out of aluminum on the CNC machine at CCIC. I also wanted to include brushless motors for quicker reactions and more torque. I needed an Arduino Nano to control the whole thing. I needed a battery source. This would be a 9-volt battery or a portable charger, something of the sorts that could fit in my rocket and power everything. I also needed to find an optimal rocket design. As you can see, they come in all sorts of shapes and sizes, so I need something that would have a fittable payload, a good nose, a good fins, anything that would work. These are my advisors to this project. My expert advisor, Logan Thompson, he's a systems engineer at Lockheed Martin. He also has a Bachelor of Science in Aerospace, Aeronautical, and Astronautical Engineering from CU Boulder, Skill Buffs. My supporting advisors include Mr. Clinton. He's a teacher over at CCIC. He teaches CNC Machining 1 and 2, and he helped me make the reaction mill and make sure my cam was working. My other supporting advisor is Ben Callan. He's also a senior here at Grandview High School. He's a student technician and student assistant at CCIC, and he's a high school technician at Lockheed Martin. He also has worked with Arduino and flight controllers in the past, so I figured he can help me with my electronics and coding. This was my original timeline. In October, I planned to do all my research. Then in November, I had to start to figure out how to work with my flight controller and how to start incorporating my reaction wheels. In December, I was going to start connecting everything and making sure everything was working in real time. In January, I was going to start making my rocket and continue working on the reaction wheels if I needed them. In February, I was going to finish my rocket and probably design it. In March, I was going to research all the safety precautions and find a good launch site that would be suitable for my rocket, so I didn't hit. In April, I would fix anything that would be broken on launch, and I'd work on this final presentation. My objectives for this project were to learn how to work with Arduino Nanos. That's something I've never done before. I took an AP Computer Science principal class freshman year, and as seniors know, that was 3 years ago, and I don't remember anything. So I wanted to get better at public speaking and presentations. I also wanted to get better at planning, trying not to procrastinate to the last minute. I also wanted to gain exposure to the engineering process and learn what that would be similar in college. I also wanted to get better at researching, and I also learned a lot about how much research can impact our projects. So this is what I found from all my research. I wanted to use an Arduino Nano for its small size and capabilities. I also wanted to use the MPU 6050, which is an electronic gyroscope that could output my roll, yaw, and pitch angles on my rocket. I also decided to use the basic breadboard and wires, since all of these connections are reversible and it's easy to use. This was my first working prototype. Here you can see the Arduino Nano, this is kind of a controller. Here's my MPU 6050, this is the gyroscope, and then here's an OLED display. It's just a TV screen that shows what it is. And then here's it working. You can see as I move the gyroscope, the angles change on the OLED display. It's kind of hard to see, but working at times. All right, so then I had to start thinking about my rocket. How was I going to design something that would fit these electronics and be able to fly a good amount of height? Well, I'd start looking into parachutes, shock cords, motor holders, anything inside the rocket that would be able to make it launch. I also had to consider what motor to use. Since we have a lot of airports and a lot of Air Force bases around us, I did not want to get shot down by an F-18. So I had to make sure I got a good motor to make sure it didn't go too high, but it got high enough to get my rocket off the ground. I ended up using an F-class motor, which is a mid-power motor. This would make it go 600 feet in the air, and it's still legal. I don't have to get a certification, and probably vocation. So for some roadblocks. Going into winter break, I tried to upload my code onto my Arduino. And sure enough, the code works great, but it would not upload for the life of me. I looked up every discussion board, I researched everything you could do, reset my Arduino, used a different Arduino, it wasn't working. So I called over Grant Yoder, who's in my class, and he's a coding genius, and he just looked at my Arduino and said, oh yeah, you just have a different chip. So all I had to do was install another library with a Mega 328P chip. And sure enough, it downloaded and worked just fine, like you saw in the photo. Also going into winter break, I was very busy. As you guys know, you're all high schoolers. Finals can get really busy. And then you have Christmas, and then of course, I decided to get my Wizard Sheet removed. And as you can see, I was not doing very much for my projects. So this put me a little bit behind schedule. So I had to change my schedule just a little bit. In February, instead of finishing my rocket parts, I was going to finish my reaction wheels and connect my motors. In March, instead of researching and testing, I was going to continue to design my rocket and maybe look for safety precautions. In April, I was going to fix anything that was going to be broken, and now I was going to launch and then again fix anything and work on this final presentation. So I had to order a few more things. First, I needed a camera that would strap onto the rocket and prove that my reaction wheel worked mid-flight. I also needed to order my motors and my motor driver through Controlled Reaction. These were the cheapest ones I could find, and they worked just fine. So I had to consider what rocket should I use. It was starting to get into about March. I did not have time to print a full rocket, especially to this size. It just was not going to happen. High school gets very busy, and I had a lot more to do with this project. So I decided to look online for an existing model rocket design. I found this AirX on Apache Rocket Components. It's a very good website if you're looking for model rockets. This was going to be about 3 feet long, and it was projected to launch about 600, 700 feet in the air using the right motor. And it had a good area for my payload, so I figured this would work just great. It also came with a parachute, shock cord, anything of the internal components that I would need, it worked. Along with the box, it also came with simulation. So I could test what motors to use, and I could test how high they would go, where they would go, what's the radius, will I hit anybody? So I used a lot of that. I inputted my electronics in here using these masses. I used my reaction wheel, that's going to be about 200 grams. And I tried to account for the center of gravity here. This projected in that little launch you see there. So the building process took about 4 hours just to build the rocket you see there. It was a very long process. We used 5-minute epoxy, super glue, and through trial and error, it eventually all stuck together. We also decided, since I'm going to Boulder this fall, scope buffs, I want to design it like seeing Boulder's colors. I hydro-dipped the nose cone to a little like tie-dye gold and black, and then I also sprayed it on 2 horns on the sides. Okay, now back to the boring part, electronics. So I had to connect my motor and my motor driver. This meant I had to research a lot of connections. Again, something I've just never done before, so it was definitely a learning curve. I also had to find an optimal battery source to charge everything on this board. This meant I had to use a 9-volt battery. This was the smallest I could find, and it was projected to support all of this. Again, the coding. So I had to code. I had to spin the reaction wheel based on the yaw outputs in an MPU 6050. was quite the task, and it took me about a few weeks to get it all working properly. I had to learn how to declare the pins on the board. I had to learn to create the loop to determine which way to spin the wheel and how much to spin the wheel, based off, again, the yaw outputs from the NPU. And of course, with coding comes roadblocks. So of course, I tried to download it onto my Arduino, and again, it didn't work. So again, I researched every discussion board I could find. I looked up, Arduino, why isn't this working? They were not responding. I tried a new Arduino. I tried anything I tried wasn't working. So once again, I called over Greg Witter, and he helped me fix the code. We worked on it for about an hour out of class. It was not very fun. But eventually we were like, let's just plug it into his computer, press download, and quickly switch it over and hope it doesn't notice. And sure enough, it didn't notice. And somehow it worked. I still don't know how it works. I probably couldn't do it again if I'm honest. But that's all I needed for code. So this is a working prototype from that code. As you can see, I'm going to twist the NPU and change the angles. And then this motor is going to change directions. It's kind of hard to see, but it should change directions based off the roll. All right, so the electronics were working. So now I need to get my reaction. At first, I thought I'd print out of aluminum, since that was the easiest thing to mill on a CNC mill. However, once printing it, it turned out to be 20 grams when it needed to be 200. It needed to be 200 due to the weight of my rocket already. If anybody's taken physics, you know that a heavy reaction wheel is going to turn better than a smaller reaction wheel. So I turned to my support advisor, Ben, and I said, hey, do you know of any density finds? And Lockheed donated a nice chunk of titanium that we could use, which turned out to be very hard to cut. You can see here it's cutting very, very slowly. So with this titanium, we broke 2 drills. It was very dense material. You can see when we were trying to drill one of the pockets here, the drill just broke off right there. Oops, sorry, Mr. Clinton. And so then we had to drill the hole in the middle for the motor to hold on to. And sure enough, the drill broke inside the wheel. Well, that's in there forever now, so sorry. If he wants it back, he'll have to drill it out himself. So then we finally got a somewhat working wheel. Of course, the hole that the motor was supposed to go into was very small, but we figured we could make it work. So I also had to print off a motor holder to put in the rockets, that way the motor doesn't move around. And then I tried to epoxy the reaction wheel to the motor in that hole, it's kind of hard to tell, and it just was not sticking. Titanium is too heavy, too dense, and that epoxy was just not good. So I ended up using up my last reaction wheel, the aluminum one, and I glued it on top of the titanium one to make a bigger hole. Once I put the epoxy in there, it finally stuck, and that was not coming out for a long time. I also decided, instead of using 9-volt batteries, I was going to use a portable charger we had laying around my house. My dad plays disc golf, so we used one of those. We plugged it in, and I put it into the top of this nose cone. You can kind of see where I drilled it in there. It's a little bit broken from, you'll see later, but I drilled it in there, and I powered the whole board, the motors, and the motor driver. So of course, there wasn't enough room. There's about a foot of room in the payload bay, but of course that was not enough for my breadboard, my motor driver, my motor holder, and my reaction wheel, and of course my battery. So I had to switch over to a smaller breadboard, and I had to get rid of the OLD display. All the OLD display did was show the angles, and I didn't really need to see that if it's 500 feet in the air. So I took that off, I switched onto a smaller board, and by squeezing and pushing, I got everything to fit. And if you see here, you can see it spinning. It's kind of hard to see, but based off the overall angles of the NPU. So now it's finally time to launch. I had to find probably the cheapest launch pad I could possibly find. What you see here is just a bunch of PVC pipes, a little metal plate, and a giant metal rod. I also needed a launch controller, again, the cheapest one I could find. All it needs to do is ignite the motor. I also needed a motor. It's very small in size, I would say. I feel like you'd expect it to be bigger, but it ended up working just fine. So I also had to find a launch site. This turned out to be one of the hardest parts of the project, since not a lot of people want you burning their grounds. I wanted to launch with this crash organization. It's the Colorado Rocketry of Space Hobbyists. Didn't know we had that, but we do. And they were going to launch up in Fort Lupton almost every weekend, but they've had to cancel the past 3 weeks due to high winds and, of course, on Saturday, snow. So yesterday, I actually went out on my own. I like to make things last minute. I went on my own. I found Salisbury Park, which is an equestrian park. And over here is an open field. There's no runners, there's no baseball fields, and of course no horses. So I thought I'd go over there. This turned out to be a nice open field, as you can see here. There's a few dirt mounds, but ended up working. That's the rocket on the launch pad. I connected everything. I turned on the camera. I went to press launch, and it exploded. I'm kidding. Absolutely. It just stayed there for about 2 minutes. We thought maybe it'd launch. It did not launch at all. So we start looking, oh, is everything hooked up right? What went wrong? And sure enough, I don't know the difference between a C battery and a AA battery. So I may have put those in wrong. As you can see, that doesn't really fit, but that looks like it does fit. So we're going to make a quick Walmart run. We got the right batteries, and sure enough, when we turned on the controller, the light turned on this time. So it was finally time for the actual launch. Here I am, squatting down, the launch controller at my feet.
Oh, I did correct myself.
I don't know if anybody's ever launched a model before. There is supposed to be a parachute. It's not supposed to nosedive like that. So, as you can see, it did quite a bit of damage. This used to be together, and it used to be not broken. Of course, the nose cone. And then here's the parachute. It's in there, I promise. It's camera shy, I guess. So, did it work? Well, kind of hard to say. My reaction wheel was turning inside, and when it was sitting on the launch pad, it was spinning. When the wind would spin it one way, you could see the reaction wheel try to spin it back. But the on-flight camera that I had hooked up right here was on and recording, and then my wonderful support advisor, Ben, accidentally pressed the off button and trying to fix the igniter. So, I have no on-flight footage, which is a real bummer, but I have a lot of cool pre-flight stuff, so if you guys want to see that. I feel like the reaction wheel did work. Of course, it's hard to say that it did stop it from spinning, but I like to believe it did a little bit. So, like I said, this was the aftermath. You can see where it kind of, as we like to say in the business, tombstones right there, the nose cone. It's kind of hard to see, but there were just wires and pieces everywhere. My Arduino completely split in half, my breadboard completely broken. Yeah, like I said earlier, the motor was supposed to launch at 133 miles per hour, so I have a feeling it might have died at probably 133 miles per hour, which is not. Yeah, so this is my bibliography. This is all my research, including what components to use, how to fix my Arduino, and what rocket to use. Any questions, anybody? Yes,
so you mentioned the weight of your reaction. How much did the actual rocket itself weigh?
So I wanted to aim for about 800 grams. That's what my simulation said. And then after adding the portable charger, it ended up being about 1,000 grams, maybe 1,200 grams. Yeah, a little heavier than